Hello students, and welcome to our continuing lesson on inverse trig functions, and we are going to do a graph of the inverse cosine function, but this time with some transformations. And so it's helpful before we dive into this example to look at the original inverse cosine function. So this is just kind of a quick sketch of this, but we'll still try to make it as accurate as we possibly can. So remember that the inverse cosine function goes from -1 to +1. From on the range, it goes from 0 to pi. And so this right here is pi over 2. And then it basically makes this sort of shape. And so we should be able to think about this and make some good transformations here. This is a vertical shrink by 1/2, and this is a shift up by pi over 4. And for this one, we have to do the shrinking first. Okay? So we basically take this picture and we shrink it down. So this point here used to be, this is 1, 0, and this point here is -1 pi, and this point right here, the y-intercept, is 0 pi over 2. So if everything gets shrunken down, so if we do the shrink, the point on the corner here, this point in the corner, so we're going to have a graph that looks kind of like this, where it's going to be -1 comma pi over 2. This point in the middle here, it's going to get shrunken down to 0 pi over 4, because it's just 1/2 of all these values. And this point right here is relative, it's basically unaffected. It's going to be 1, 0. So if we think about it in that sense, it's easier to picture and draw this. And notice here, I'm doing this entire thing without having to use a calculator. And then let's say what happens if we do the shift? Well, if we're going to shift up pi over 4, this point here becomes -1 pi over 2 plus pi over 4. The point in the middle here becomes 0 pi over 4 plus pi over 4. And then the point on the right here is going to become 1, 0 plus pi over 4, or just pi over 4. So what I'm doing here in this case is I'm taking all of the y values and I'm just adding pi over 4 to it. And so now with that we have enough information where we can actually put all of this on the graph. Okay. So let's see. I need -1 and I need +1 to show up on the graph. I need the top of this to go a little bit higher, so we'll go, I mean, it's still going to go to pi, and then the bottom, well, it doesn't really matter, but I'll put it in here anyways. And I know that this point up here is -1 3 pi over 4. So that's about right here. This point in the middle here is 0 pi over 2. And then the point down here is, oops, a little bit higher. So it's at 1 pi over 4. And it looks roughly like that. So it's basically we've taken the original graph, we've shrunken it down, and then we moved it up. And you can see the result here. And we can, of course, certainly analyze this. It's not too difficult to do. The domain is everything still from -1 to +1. The range changed a little bit here. It's everything from pi over 4 to 3 pi over 4. Those are all of the y values. The symmetry is still none, so nothing's changed there. Let's see what else. Oh, the y-intercept. I don't know if the proper particular answer is, but we can say that the y-intercept is 0 pi over 2. What else is there? Well, there are no real extrema here to this, and that's about it. We can end it right here. Oh, I'm sorry. I realized I said something there that wasn't quite accurate. There are some extrema. There is an absolute max at 3 pi over 4, and then an absolute min at pi over 4. Okay. And usually you can tell if you're going to have absolute max and min when you have a bounded range like this. There is no end behavior in this case because the domain is bounded. Because this graph is bounded. And also it is always decreasing the entire way. So it's basically a graph that always goes downwards or always has a negative slope of some sort. Okay, and now we can end it here that we got some more information and I've told you all of the accurate information.